Hello, Rian. I'm audible. Okay, so fine, guys. I think I'm audible to Rian of you. Yeah, so let's start with the class. Okay, so fine, it's time. So fine, guys. Good afternoon. So anyone who can tell me what we have discussed yesterday? I think we have discussed like a 4 to 5 topics, right? Yesterday. Yeah. Okay, so we talked about realization. So I think we talked about L1, we talked about L2, we talked about elastic, right? So rigid lasso, or you can say lasso and rigid and elastic net. This is something that we have discussed. We talk about multicollinearity. So we talked about Pearson correlations. We talked about VIF, I assume, right? So variance inflation factors. We talked about p-values. Yeah. So I think these are the topics that we have discussed. We talked about a feature selection. So what kind of or how we are supposed to decide that which features are important or which features are not important by using some of the statistical approach. And that approach is nothing but OLS kind of approach that we have already discussed. Apart from this, so we talked about adjusted R square. So in a like previous classes, we have discussed about R square, and we know that R square is 1 minus RSS divided by TSS. Then we have talked about adjusted R square. So we have seen that where your R square is going to fail, and keeping these things in our mind, so we are supposed to adopt adjusted R square as well. So here in today's class, we'll try to see an implementation of all of those things that we have discussed. So let me share my screen and let's get started. Yeah, so let's try to talk about this entire topic in detailed way. So I think my screen is visible to everyone, right, guys? Everyone? Yeah. Sir ने light लगाई है आज. Okay, so fine. Let's start talking about these topics. Okay, so before this one, so let me share one of the data set, right? So one of the, again, a very simple data set where we can try to implement each and everything, and we are going to discuss about it in detail. So here is a data set, guys, in your chat box. So just confirm me once you are able to see it. You have not shared a notebook yesterday. Yeah, I'm just using a same notebook. So what I will do is, so I'll try to share only one notebook. So previous version of this notebook is already available. Whatever I have added, it's available in a same notebook. So linear regression part 1, and even today, whatever experiment we are going to do, so everything will be available in a single notebook. So that will be uploaded. That's the reason. So I have not uploaded yesterday's like a notebook. Okay, so fine, guys. I think data set is available to all of you, right? So let's start working on this particular part, start working on this particular data set, and let's try to understand so how we can try to implement these kind of operations, right? So here we will try to import some of the things, some of the libraries, right? So maybe pandas we can try to import. So import pandas as PD, and start typing, guys, along with me. Import numpy as np, and then we can try to import scikit-learn. From sklearn we can try to import pre-processing, and from there, so we can try to import maybe a standard scaler. And then again from sklearn we can try to import, from sklearn we can try to import maybe a linear model, so that I can see all the things that we have discussed yesterday. So rigid is available, and then lasso is available over here. Yeah, so rigid is available, lasso is available over here. Again, rigid CV is available. So rigid CV is available, fine, and then lasso CV is available. Lasso CV is available. Elastic net we can try to import. Elastic CV we can try to import. And then we can try to import maybe a linear regression. Fine. So this import is done. Now, apart from this, so maybe we can try to do an import for a linear regression. So from again sklearn, from sklearn, we can try to import the model selection, and then we can try to import train test split, and then we can try to import stats model dot API and as sm maybe. Then we can try to import maybe matplotlib dot pyplot, maybe plt, and then we can try to import cbol as sms, right? So fine, guys, these are the imports that we are going to use. So yesterday we talked about a rigid, lasso, elastic. So yes, these are the things that we are going to use. We are going to use a linear regression model, right? And apart from this, so we are using a rigid CV, lasso CV. This will be a lasso. So rigid CV, we are going to use a lasso CV. We are going to use elastic net. We are going to use elastic net CV. Now, what is the CV? So because we all know about a rigid, lasso and elastic net, but we are not aware about a CV, a cross validation, right? So I'll be talking about this new concept called as cross validation. We have not done, or we have not used train test split so far. So I'll be talking about that while doing an implementation. So we have not used standard scaler. So I think we all have discussed about this standard scaling technique in a statistics class, but we have not used it so far. So we are going to use even a standard scaler in your today's class. So these are the imports that we all are going to do. So I'm assuming that we all are able to type all of these things inside your Jupyter notebook. Yes, can I get yes or no? Yeah, so I've already pinned you a code, guys, which is available inside your chat box. So please try to copy and paste if you have not typed, but yeah, typing is advisable. So today we'll try to do a lots of typing practice. Okay, now can't copy anyway. Yeah, that's fine. So try to type it. Fine. Okay, so once I will be able to import this entire things, then what we have to do? So then we are supposed to import our data set. So I think I have already shared this data set link with all of you, right? So those who have not received this data set link, so I'm going to ping you this data set link once again. So here is a data set link again pinged inside your chat box. Yeah. So fine. So once just try to import this data set. Just try to like download this data set inside your system, and then you can confirm me. So once you are able to do it. Okay. Okay. Now, wait, sir, link ko type karna pad raha. Okay. So I think you can try to select just try to do control A, and you will be able to copy this entire link. I have checked it, so it's possible to copy this particular link. Whatever I'm going to like share with all of you, and some of you are able to do it. Yeah, click it and it will work. So it is actually working. So you can click over there and then it will work. You will be able to copy because I have tested it. So once you have raised your like complaint, right? So after that we have already tested it, and yes, it is like working. No, just try to click it and control C. You will be able to do that. Yeah. Okay. So once we all are able to import a data set, again, this is the open source data set. You can download it even over the internet. That is completely fine. Even we have downloaded this data set from our internet itself so that we can show you this kind of applications. So it's completely fine. We are going to experiment some of the things with admission prediction.csv data set, which is widely available. So you can try to download it from anywhere. Yeah. And open Zoom meeting in browser. So it will work. So I think Mohit is giving you a suggestion. Okay. Fine, guys. So once we are able to do it, now what we have to do? So now maybe we can try to import this particular data set. So yeah, let's try to import it. So to import this data set, maybe I can try to type pandas.read CSV. I think we all are aware about it. And then inside that, so we can try to copy this particular data set name. So pandas.read CSV, and this is the data set that we have. Now let me talk about a data set in a very first place. So what is this data set and what are the details about this data set, right? So here inside this data set for admission purpose, right? Different kind of a parameter or different kind of a features are given to you. So let's suppose if I'm trying to take admission in some colleges, so they are going to check some of the marks, some of the performance, right? My previous track record and many more things they are going to see. And then only they will try to tell you that, okay, whether it's possible to take an admission into a colleges or it's not possible to take admission into a colleges. So this data set is again all about taking an admission in a particular colleges. So where you will be able to find out a serial number. This is nothing but equivalent to indexes, a numbering of the data set, or you can say a row record, right? And then you will be able to find out a GRE score. We all know that if we are going to take admission in some of the international universities, so over there, GRE score, TOEFL score, my like a history, or maybe in which company I was working, all those things matter. So in this data set, your GRE score is mentioned, your TOEFL score is mentioned, university rating is mentioned, SOP is mentioned, LOR is mentioned, CGPA is mentioned, research, whether you have done some research or not, this is mentioned 1 or 0, right? And then there is a column called as chance of admit. Chance of admit is nothing but it is telling you that, okay, whether there is a chance to get admission into a particular college or not. So this is the very simple data set. Again, as I have mentioned, it's an open source data set that we have already considered or we have taken. Now, what is a requirement over here? A requirement over here is very simple. So we have to build a model, right? So we have to build a model where if I'm going to insert or if I'm going to give all of these parameter, selected parameter, right, on my screen. So GRE score, TOEFL score, university rating, SOP, LOR, CGPA, and a research. So if these are the input I'm going to give, so my model is supposed to tell me that, okay, what is a chance of admission? So whether I will be able to get a chance or not, right? So that anyone who would like to apply for an admission, right? So they can maybe go over here and they can try to check. So at the end of the day, maybe we can try to create one simple web page, and over there, I'm talking about the deployment thing, right? So when we will try to deploy this particular model, so at that point of a time, we can try to create one particular form where inside a form, people can try to insert all of these records or all of these informations, right? So whatever records that they have, whatever informations that they have, whatever GRE score, TOEFL score that they have received, and immediately they will be able to know that, okay, I will be able to get an admission in this particular university or not. So this is a use cases. So I think it's completely fine to every one of you. Yeah. In terms of a use cases, anyone who is having any issue with respect to a use cases? No? Yeah. So this is a very simple use cases, right? And again, data set is straightforward. We are not considering any complex data set as of now because it's like a initial classes for all of us, right? So most of us are new in this particular area. So fine. This can be done via if else via machine learning. Okay, that's a good question, Sandeep. So just tell me one thing. These are the number of columns, right? 1, 2, 3, 4, 5, 6, 7. Now, again, a bracket for taking an admission or maybe calculating this score, because your score is ranging in between, let's suppose 0 to 100. So there are hundreds of instances, or there are maybe millions of or infinite number of different instances which exist. Some of them will be able to get a chance of admission is equal to 9.111, 9.1111112, right? In this way. And let's suppose in my college, only 10 position is available, right? So if I have to give an admission to someone, so based on what I will try to give, if I have to differentiate, whether, let's suppose if I have one seat, right? So if I will write if and else kind of a condition, so it will not be able to make a concrete division in between, right? Concrete division in a sense of, like it will not be able to separate a user in a real sense. So over here, because let's suppose there is a user who is having a complete chance of admission is equal to 9.22 and 21, right? In case of if else condition, so it is going to put both the user in the same bracket, but we are not looking for that kind of instances. We are looking for a very clear answer or very clear output, maybe till 8 digit, 10 digit or 12 digit, right? So where I will be able to make a decision in between two user. So for sure you need this kind of a system. And again, if you will start writing if else kind of a condition, so again you will have to like go through each and every of this data set, and you will have to understand what is a relation, right? Unless and until you will not be able to understand a relationship in between a data set, you will not be able to write if else kind of a condition. So let's suppose if I have given you a 500 rows, how you will be able to understand that, okay, fine, so on which criteria of which column, this is the score that we are able to calculate. That's the reason. So if else kind of a condition is not going to work the way we are looking for, and that is the reason. So machine learning things is applicable over here. So maybe we'll have to build a model which can learn a relation, and based out of that relation it is supposed to propose me that what is a chance of admission. So hope this things is clear to everyone. I think this question was asked by Sandeep. Yeah, so that is a reason. Okay, so we have a column over here. So we have a feature column over here: GRE, TOEFL, University, SOP, LOR, CGP, and this. These are the feature column, or X, you can say X1, X2, X3, XN values that we have, and we have a Y value, right? A Y column we have chance of admit in this particular place. And my work is to build a model by taking a feature and a label column. This is a regression problem. Again, how I will be able to identify that this is the regression problem, right? Because going forward, we'll try to understand classification problem. So regression problem means I'm looking for some of the numbers, right? I'm based out of a relation, because regression means a relations. So based out of a relation, so I'm looking for some of the numbers, some of the digits. Again, in classification, you will be able to find out that in some of the example, we are looking for again a number, but again, those numbers are fixed here. So we are looking for a number which is not fixed at all. And that is the reason. So it falls under, you can say, a regression. Yes. So fine, guys, let's try to build a model, right? But before building a model, right? So before building a model, so let's try to perform some of the operations for doing a data analysis. So guys, what we are supposed to do, by the way, I'm just looking for some of the analysis, some of the initial analysis of the data set. So what I'm supposed to do? Yes. So df dot. So maybe I can try to import pandas profiling. So I have already done that import over here. So let me execute this profile report. I think in our last classes, we were using this one, right? So profile report. So fine, no issue. So let me try to import this profile report, and maybe we can try to generate it. So profile report that to widgets, and then I will be able to see some sort of a report or some sort of analysis, initial analysis, right? Because for every kind of a data set, we are supposed to do some sort of a initial analysis. So it's completely fine. Even we can try to call data frame dot describe, and I will be able to see some of the initial analysis for sure. So let's see what happens over here. So here I'm trying to run this particular report, a pandas profiling report that we have already discussed in your previous classes, right? Which is the easiest way to understand a data set a little bit. So number of variable is equal to 9. So find number of column is equal to 9. Numeric column is equal to 7. Categorical column is equal to 2. Okay, so here we have a complete column over here, and pandas profiling is able to understand 7 as a numerical column, 2 as a categorical column, but we are not able to see any categorical column over here, right? But still pandas profiling report is giving me that some of the column as a categorical. So maybe for a serial number and for a research, so where we have 1 0 and then 1 2 3 4 5, maybe for that, or maybe for some other column, so it is trying to tell me a categorical one. So we'll try to understand that. Number of observation is equal to 500, right? missing cell is equal to 40. So we have some of the missing data set as well, and we are supposed to handle these missing data set. So in our previous data set that we have considered, in that data set we didn't have a missing data set, but here we do have a missing data set. So somehow we will try to learn that how to handle a missing data set, because there is those kind of a data set which is available, right? Okay. Now, warning wise, so GRE score highly correlated with the TOEFL score, fine. So it is telling me that GRE score and TOEFL score are highly correlated. So can I say that I'm getting some sort of a feeling of a multicollinearity over here? Yeah, just out of this initial analysis, right? We'll try to understand how we can remove it, or whether what is like a kind of a relations that we have. Maybe we can try to print a VIF score, or maybe we can try to print correlation matrices based out of that numbers. We can try to do some sort of analysis, but initial analysis says that yes, there is some sort of a correlation which is available, and six other field. TOEFL score is highly correlated with the GRE score. University rating is highly correlated with the GRE score. So there are so many correlations we are able to find out, right? Okay, no issue. Again, like reproduction, that is completely fine. So what is the durations and what was the time analysis started and ended? So this is just a log information which we are able to see. Now variable wise, so serial number is given to you, right? Serial number is given to you. I don't think that we are going to use it, because serial numbers are nothing but it's just equivalent to a index number, so it is not going to affect. So maybe I'm not looking for an analysis of a serial number column, so we can avoid this particular part. Maybe I will be interested into a GRE score, right? So in case of a GRE score, total number of distinct score is equal to 49. Again, Sandeep was saying that why we are not writing a if else kind of a condition. So here distinct is equal to 49. In other column, again, you will be able to get some sort of a distinct. So it will be difficult to write a if else kind of a condition. So number of distinct column is equal to 49, and a distinct percentage is equal to 10%. 10 missing, 15 missing values are available. So 3% of the missing values we have inside this GRE score column, right? Okay. Now infinite is equal to 0, mean is equal to, so average GRE score is equal to 316.5587, memory size negative, zeros, maximum, minimum. So yes, all of these things are given to me. Now if I'm looking into its histogram, right? So this is nothing but, this is what? This is a histogram that we have. So if I'm looking into a histogram, you will be able to find out, or you will be able to see that this histogram, right? So if I look into this particular histogram, so you will be able to see, or you will be able to sense over here that it is trying to form some sort of a normal distribution, approximate normal distribution it is trying to form, right? So fine, my data set is normally distributed. This is the observations which I'm able to get initially. Yes. Okay. So what and all other informations I will be able to see, or I will be able to get? Let's try to understand that particular part. Okay. So this is the histogram that we are able to see, right? Again, so if I'll try to click on toggle details, so maybe minimum, maximum, first quartile, second quartile, variances, monotonicity, skewness of the data set, kurtosis, all those things I will be able to find out. This is the histogram, same histogram that we have observed. Common values, yes, that is completely fine. What is the stream values? So there is not much stream value I'm able to find it out. So likewise, maybe we can try to talk about other columns. So TOEFL score, again, there is a missing values over here. University rating, again, there is a missing values over here. SOP, there is no missing values. LOR, no missing values. CGPA, no missing values. Research, no missing values. Chance of admit, no missing values. So there are some missing values that we have in some of the columns. That is completely fine. Interaction wise, so maybe we can try to understand that what is a graph that I'm able to get in GRE versus chance of admit. So can I say that in case of GRE versus chance of admit, we have some linear relations? Yes. So I'm supposed to build a model, right? and we are trying to learn a linear regression. So if there is no such kind of a relations which is available inside a data set, then how I will be able to decide that we are supposed to use a linear regression? So here, yes, we are able to see a concrete evidence that there is some linearity which is available in between a data set. So probably I can go ahead with the linear regression. There is a possibility over here. So maybe TOEFL score versus chance of admit. Again, it's a linear one. So why I'm trying to compare everything with chance of admit? Because chance of admit is my Y column, right? Or I can say my label column. Again, SOP versus chance of admit. Yes, there is some linearity. LOR versus chance of admit, some linearity. CGPA versus chance of admit. Yes, there is some sort of a linear relations which is available. Excuse me. But intensity of this linear regression is not, linear relations is not same everywhere, right? So it's not like a same in all the cases, but yes, there is some linear relation. So I think we are going good, and we can try to implement a linear regression algorithm over here. So this is our verifications which I would like to do, and yes, we have already done that. Again, this is a Pearson graph, right? So this is a Pearson graph, and everywhere you are able to see anything versus anything in blue majority of the time, right? Or it is attending towards maybe 0.75 or maybe 0.50. Can I say that? What is the meaning of this graph? So what is the meaning of this graph, guys? So can I say that there is a multicollinearity that we have? Yes. So we have a multicollinearity in between a feature, and I think we all understand a meaning of multicollinearity, right? We all are aware about it. So I think it's completely fine. There are some data set which is multicollinear. Maybe we can try to talk about it, right? Okay. Now, so if I'll talk about column wise, so here 500 data, 485, 15 is missing, 10 is missing, 15 is missing, no missing data, no missing data, no missing data, no missing data. So in 3 columns, we have a missing data. So can I say that I have to handle maybe a multicollinearity, as well as I have to handle maybe a missing values over here, right? So these are the situations which we have to handle with respect to this data set. Last time, so we have taken a data set, it was a completely flat data set. So we have not done any kind of a data pre-processing over there. We were using those data set directly. But in this data set, right, there are some sort of a implementation, some sort of a analysis, or some sort of a like a improvements I'm supposed to implement. Otherwise, my data set is not that great over here in this case, right? So fine, not an issue. So this is the initial observations that we all are able to see. It's completely fine. So based out of my initial observation, so maybe I can try to perform a different kind of a relations over here. Yeah. So let's try to perform some of the different kind of operations based on our initial observation. Okay. So fine, let's start typing code again. Yeah. So fine, we have a missing data set, right? And I think all of my data set is available in a form of data frame. So these are the data set which is available over here, available to me as a data frame. Now what I can do is, so maybe we can try to, because there are some missing values in university rating, or I can say TOEFL score, or maybe in a GRE score. So one by one, we can start handling this missing value in like in a certain sense. So fine, what I can do is, so maybe data frame that we have, and then we can try to write GRE score is equal to, so maybe we have to fill a missing data, right? So maybe I can try to call fill NA over here. So I think in our pandas, so we have already studied this fill NA kind of a things, forward fill, backward fill, fill NA, many things we have discussed. Or going forward, we are going to use imputers. So this is initial examples. That's the reason. So I'm not going to use a imputation technique. This is also one of the imputation technique, but going forward, when we will end up learning this linear regression or k-mean or different algorithms, so there are a different kind of imputers which we will see. So where imputers based on the prediction of an entire data set, it will try to fill up my missing values. That is also possible, but as of now I'm not going to use it, right? I will be using a very simple approach over here. So maybe a data frame of a GRE score, right? So data frame of a GRE score, I can try to type. So fill in a this particular like a data set with what? So maybe with a average. So I'm saying that, okay, just do one thing, right? So try to perform this operations or try to fill this entire data set wherever we have null values with what? With an average of the same column. So execute, right? So what is the issue? See, not attribute fill NA. Okay, I think I have mentioned 2 times NA. Fine. So here we are able to fill it now, right? So in this way, wherever we have a null values, it is going to replace all of this null values by what? An average of the same column, right? And it's completely fine. So someone is saying that can we use a fill in a and then we inside that in place is equal to true. So yes, you can try to use in place is equal to true, but as I'm trying to do a reassignment operation, so both is going to work in a similar manner. So it's completely fine. You are not supposed to use it here. So average of like a GRE score we have used, and with that, so I'm just trying to do some sort of a imputation. This is not an exact way of filling a missing values, and this is not a exact. So this is one of the way I would say, but this is not a best way. So best way will be a imputation or by using some sort of a imputers. But as I have mentioned, this is the initial classes, so I'm not going to talk about it unless and until I will not end up discussing certain algorithms, because those knowledge of those algorithms are important and it's required. Then only it makes sense that we are going to use those imputers. Otherwise, it doesn't make sense. Okay. Now here, one column is fine. We had another column, right? Inside a TOEFL score. So we had some sort of a missing values. So again, I will try to perform these operations and I'll try to fill all the null values which is available inside a TOEFL score. So this column dot, maybe I can try to like write fill NA over here, and then we can try to fill this entire things with what? Maybe an average of this particular column, mean of this particular column, and then it's completely done. Then we had a third column, I think university rating. So where we had a missing values. So maybe I can try to call data frame of this particular column, and then we can try to do this dot fill in it, and dot, maybe I can try to call mean, right? And in this way, I will be able to do some sort of a imputation. I can try to perform another operations as well. So maybe I can try to do some sort of a mod operations. I can try to fill all of these values by using a mod. So mean, mode, or maybe a median. I think we all are aware about it, right? So what is the meaning of mean, mode, and median? It's completely fine. So I can try to use any of such kind of a things, or maybe I can try to use a backward fill or maybe a forward fill. I think we all know how backward fill and forward fill works. Apart from this, so we can try to use even an algorithms to fill this entire missing values. Yeah. Now, if I'll try to check data frame dot describe, so data frame dot describe, if I'll try to call, so do we have a missing values now? I don't think so, right? So we don't have missing values as of now. So count of each and every column is now become 500, 500, 500. If you will try to compare with the previous result, right? So it was 485, it was 490, and it was 485, right? Now it became 500, 500, and 500. So successfully, we are able to fill out these informations. Or you can try to do maybe a data frame dot is null. right, is null, you can try to call dot, you can try to call a summation, and even in this way you will be able to know that whether we have some missing values or not, right? So yes, that is completely fine, we don't have any kind of a missing values, so we are good. So far so forth. Now once we are good with these kind of informations, or this with respect to this missing values, then what we are supposed to do? So can I say that serial number column we are not supposed to use? It is just like giving me some sort of information about the indexes. So I believe serial number is a column which is not of our use, so maybe we can drop it, right? Okay, so let's try to drop it. This is the next process. I'm just trying to prepare my data set over here. So I will try to drop this particular column. I think we all know about a code, right? So we can try to call maybe a data frame dot drop, right? So we can try to call this drop, and then we can try to write maybe columns is equal to what? So my column is nothing but it's a serial number. This is the name of the column. So fine, no issue, I'll try to just drop it. Yeah, so drop it, and now this is done. Again, if I'll try to print my data frame, so here we have a serial number. So what we are supposed to do? So can I say that we are supposed to like write over here in place is equal to true, or maybe I can try to do some sort of a reassignment operation, right? So both is completely fine. Now it's gone. Yes, now we don't have a serial number. So we have GRE, TOEFL, University Rating, SOP, LOR, CGPA, Research, and chance of admit. Fine. So this is completely fine. We are able to drop it, right? Someone is saying that access writing is required. No, I have already written column, right? So by default, it will be able to take a columns, as simple as that. Okay. So are we good? Are we all able to do that till this particular point? Anyone who is having any issue? I'll give you time, maybe 2 or 3 minutes. If you are lagging behind, or maybe if you're not able to do it, do it. Yeah. Why place in place is required? I think when I was talking about these things in my Pandas classes, I talked about in place in a very clear manner, right? Yeah, okay, fine. So we all are good till this particular point, right? So what we can do now over here is that we can try to maybe, now we all know that what is a trend inside a data, right? We all are aware about it, that okay, so what is a trend inside a data set, or maybe what kind of a graph data set is giving me. So we all are aware about it, or what kind of a distribution we have with respect to what kind of a data. So we all are able to get those kind of a information. So no need to write those lengthy code to plot graphs, or maybe to do some sort of a analysis, right? So here, right, so here what we can do is, so once this particular like thing is fine, once we are good with our relations, or once we are like good with all of this information, so maybe we can try to create our x and y over here. So let's try to create maybe x and y. So what will be my y column? So can I say that my y column is nothing but, or my label column is nothing but, right, chance of admit. So fine, what is my y column? So my y column is nothing but data frame of chance of admit. So this is going to be my label column as per my use cases. Okay, so y. Now what about my x? So my x is nothing but, so maybe I can try to call data frame dot drop, and then I can try to drop what? So maybe I can try to drop columns, and what is a column over here? So maybe I can try to drop chance of admit, and that will become my x values. There are other ways as well to create my x or feature column. So now if I'm going to print my x, so this is my x, and if I'll try to print my y, so this is my y. So can I say that now we are able to create our feature and labels? So we have our own feature, right? And we have our own label. So are we good till this point? Yeah. So we are kind of good with respect to this point. So we are able to create our X and we are able to create our Y. So your Y is nothing but chance of admit. So select that column, and your X is nothing but except chance of admit, rest of the column after removing your serial number. That's the only thing that we all have to do. And I think we all can do it very easily and quickly. Yes. So fine. Once this steps is done, so once we are able to like perform these kind of operations, so after that maybe we can try to perform some sort of a normalization operation, or maybe some sort of a standardization operation we can try to perform over here. Now, why normalization or some sort of a standardization operations is important? Let's try to understand that particular part. So if I'll go back to my pandas profiling, right? So if I'll try to like go back with respect to my pandas profiling, and if I'll try to maybe check a different columns over here, right? So can I say that ranges of the data set that we have in a different column is varying a lot? Yes, a data set range for all of these columns are varying a lot, right, in between. So if these data set values are varying a lot, so maybe we can try to call a standard scalar, and we can try to bring down this data set in a lower label. The problem is it's not like it's mandatory. We can try to use this data set directly. There is no issue with that. But the problem is that if you are not able to, or maybe if you are not able to bring down your data set in a lower scale, it will be tough for my model to understand our relations, our concrete relations, right? So if I will be able to bring it down maybe on a lower level, or maybe on some lower scale, without changing a meaning of a data set, so maybe in that way my model will be able to understand, learn, and build a relations in a better way. And that is the only reason. So we are supposed to do what? So we are supposed to apply some sort of a normalization technique, some sort of a standard scaling technique. And that is the reason. So if you remember, we have done an import for standard scalar, right? So we have already done these things for a standard scalar. So now let's try to do one thing. So maybe we can try to import this standard scalar. Yeah. So we are trying to create an object of a standard scalar. Now, what standard scalar says? So standardize a feature by removing the mean and scaling to a unit variances. This is what it is going to do. A standard score of sample X is calculated as this much. So can I say that this is nothing but a Z statistics we are talking about? And it's the same Z statistics that we have studied in our statistics class. So data minus average divided by standard deviation. Yes. And what is the meaning of a standard scalar? So can I say that meaning of a standard scalar is nothing but mu is equal to 0 and standard deviation is equal to 1? Yes. So can I say that we are shifting our entire data set where mu is equal to 0 and standard deviation is equal to 1, right? So mu or mean, you can say. So this is something that we are trying to perform, right? And this is the exact same thing Chris has, I think, discussed in his statistics classes, right? We all used to discuss this kind of things, even in my pre-recorded session. So these things are discussed in a beautiful manner in your dashboard, which is available inside your dashboard, right? So that is, so it's like a pretty much obvious statistics concept, right, that we are trying to implement over here. This is what a standard scalar does. So going forward, if someone is going to ask you, first of all, that why standard scalar is required, right? The answer to that question is that if my data dispersion is varying a lot, if my data set is having a lots of variances, so maybe in that case, my model will not be able to understand a relations, or it will not be able to find out some sort of a relations with respect to a features and label in a better way, right? So just to find out a better relations or a strong relation between a feature and a label, so I'm using standard scaling. How a standard scalar works? Nothing but a standard scale, nothing but just a Z statistics, right? It's the same stats concept. Again, you are able to find out a same formula over here. Nothing fancy or nothing new we are discussing over here. We're just talking about the implementation of the things that we all have studied in our previous classes, right? Okay, fine. So this is a standard like a scalar that you will be able to find out. So again, same definition, right? There is no changes that you will be able to find out. Standardization of the data set is common requirement for many machine learning estimator. They might behave badly if individual feature do not more or less look like the standard normal distribution data set. So if your entire feature is not dispersing normally or maybe as a standard, so for most of the machine learning algorithm it is difficult to find out the relations, because machine learning algorithm does nothing. It just try to find out that, okay, fine, so where error will be equal to 0, or difference between y and y hat will be equal to 0, or my losses will be equal to 0. This is the only point it will always try to figure it out, right? Now just to give maybe some sort of a support to my machine learning algorithm, so we are trying to utilize this one, right? So Gaussian with the zero mean and unit variance is called as standard scalar. So we all are aware about it. There is nothing new that we are discussing over here now. So yeah, this is the RBF kernel, all those things which will come in future classes. What is the meaning of radial bias function or kernels? So fine. So we are trying to create an object of the standard scalar. So now this is the object of the standard scalar class. What we can do is, so maybe we can try to call this object, scalar object that we have created, dot fit transform. So fit transform, and what we will try to fit our feature. So now this is how my feature looks alike, right? So this is how my feature looks alike in this particular case. Now if I'll try to store these things maybe into a data frame 1, so df1, if I'll try to store it over here, or let's suppose this is not a data frame, by the way, this is the np array, numpy array it is going to give you. So let's suppose I'm going to store these things in array arr, right? So this is how my arr looks like. And now if I'll try to convert these things into a data frame, so pandas dot data frame, and maybe I can try to give arr, and this is a data frame that I have prepared, and data frame 1 is equal to this much, df1 dot maybe profile report I can try to generate, and let's see now. So we can try to compare, and we will try to observe that whether we are able to convert our data set in a normal distribution or not. Sorry, it's a df1, right? So I have done just for df. Yeah. So now this is a data frame that we have. Okay, so let me plot, or you can see a graph, right? And you can try to match the same graph with a previous graphs. You will be able to find out that now my graph everywhere you will be able to find out zero mean. You will be able to find out zero mean. Are you able to see it? Zero mean everywhere. Yes. So we all are able to see a zero mean, zero mean, zero mean, zero mean everywhere, right? In all of this. Yeah. So zero mean, you will be able to find out each and every places, right? So now this data set is what? This data set is standardized. We are not changing a meaning of the data set, because we all know that in case of a standard scaling technique, or in case of a jet transformation, so we are just shifting our data set on a different scale. If you will try to compare a same data, right? If you'll try to compare a same data last time, right? Yeah. So previously our mean was not equal to 0. Our standard deviation was not equal to 1. But now our mean is equal to 0. Standard deviation is equal to 1. So yes, we have done some sort of a standard scaling over here, so that my algorithms will be able to understand things in a much better way. So fine, no issue. This is the standard scaling technique that we have already applied. And yes, these are the array which I'm able to generate. So now this is how my data set looks like. So if I'll show you, so DF1, this is how my data set looks like. It's ranging in between some lower scale, right? In between some lower scale. So my data set variance of this data set is not very high over here. Again, I can try to generate maybe I can try to call a describe, and even over here, so you will be able to see a same thing, right? So standard deviation is equal to like close to 1, and your mean is close to 0. So e to the power minus 16, e to the power minus 15. So it's a approximately close to 0 values that we are able to receive over here in case of a mean. In case of a standard deviation, so we are able to receive what? So we are able to receive approximately close to 1 as a standard deviation, because e to the power 0 means 1, right? So again, minimum maximum differences, you will not be able to find out like a much over here. So minimum and a maximum differences, it's almost like a close and ranging in between some of the defined ranges. It's not like some of in some of the columns, so my values, some of the values are going as like a 500, and some of the values is equal to 1. Yeah. So this is the advantages that you will be able to see. So a little bit of data transformations I have done over here by using a standard scaling technique. So are we good? Are we all able to do it? Yes, all of these things. So scalar dot fit transformation. I have a question, as I cannot perform these things. It's new to me. I don't think that it should be new to you, because what I'm assuming is maybe you have not gone through our stats classes, because before your machine learning classes, we have already given you a stats classes. In that stat classes, theoretically and mathematically, we have explained you each and everything in a very clear way, that what is the meaning of a standard scaling, what is the meaning of a Z score, what is a Z values, and even the recordings which we have given to you, right? In those recordings, things are explained in a very beautiful manner by me. So I have already like those things are available in live classes as well as a previous class recording. In both the versions, these things are available. Fit transformation basically transform the data into a same time. See, fit transform is just a function which is associated with a standard scalar classes, right? And in a very first day, I think last week, I told you that you can change, if you want, you can change a name of the class, you can change a name of the function. It just depends upon you. Code is already open sourced. Complete scikit-learn library itself is open sourced, right? And we all know that what is the meaning of modules, what is the meaning of packages, what is the meaning of classes, what is the meaning of functions and objects, right? We all are aware about it. So you can go and you can just try to modify it. Maybe you can give your name on behalf of this particular function. That is also going to work fine for you. So there is no doubt with respect to that one. So just a fit transform is a standard function which has been defined. That's it. Now, so once I will be able to do some sort of a standard scaling, now, after doing some sort of a standard scaling, what I will do over here is, so maybe we can try to, so let's try to store this array. So this is the array is the standard scale data set that we already had, right? So maybe what we can try to do is, so next step is we can try to check a multicollinearity. Initially, we have handled a null value. Then we have done a standard scalar transformation, right? Now we will try to check again a multicollinearity. Last time when we have checked a multicollinearity, so there was so much of correlations I was able to get. But this is the data set. This is the new data set that we have created. This is what we are supposed to use. So I will try to check some sort of a multicollinearity with respect to this data set, right? So here, what I can do is to check a multicollinearity. Maybe I can try to do a Pearson plot. That is completely fine. Or I can try to do a VIF. So last time we have already done a Pearson plot. We all know that in a Pandas profiling, by default, it will be able to give you as a report, as a Pearson like a graph it is going to give you. So maybe we can try to use a VIF. Even VIF we have discussed. What is the formula for VIF, by the way? Anyone? I think yesterday we have discussed, right? Yeah. So 1 by 1 minus r square. And what is the threshold value for VIF, by the way? And why? Okay, someone is saying 5, most of you are saying 10. So yeah, 10 is good. And why? So import variance inflation factor. So just try to do this import. Yeah. So just try to do this kind of an import, guys. I'm just trying to import what? Variance inflation factor. Nothing else I'm trying to import, right? Okay, so once I will be able to do these things, right? So once I will be able to do this particular things, a various influence factor I will be able to import. So maybe we can try to calculate a variance inflation factor for each and every columns or each and every data set that we have over here. Yeah. So okay, let's try to do it, right? So let's try to do it one by one. So maybe we can try to check that what is the input variance inflation factor takes. Yeah. So it takes exogen and exogen IDX. Now this is nothing but it actually takes your X values, and it's IDX means nothing but it's a indexes it is going to take. So fine, no issue. So maybe we can try to do some sort of a calculation in terms of, or sort of, I can say like a VIF I can try to calculate. So let's see how I will be able to calculate a VIF, right? So variance inflation factor we are supposed to calculate. So first of all, just try to do this import and leave it. And then maybe the array part that we have, ARR. So ARR dot shape. Now, what is the shape of this particular array? So shape of this particular array is 500. So in one single column, so what is total number of records that we have? So 500 number of records. So 500 is a number which I'm supposed to extract. So how I will be able to extract this 500 number out of this one? 500 number of rows we have, right? So one by one, one by one, one by one. So I have to extract it. So how I will be able to extract 500? So can I say by using 0? I have, how many number of column do we have? 7. So how I will be able to extract a column out of this one? Number of columns. So can I say shape of 1? So find 7 column. For 7 columns, so I'm supposed to find out a VIF. So array dot shape, this is going to give me what? This is going to give me a shape. Okay. So fine, what we can do is, so maybe for I in a range of, we can write 7. So can I say that it is going to just give me it is going to give me, or it is going to iterate over to a 7, right? Again and again. Yeah. So with this one. Now here, so variance inflation factor I have to calculate. So maybe I can try to write ARR, right? So ARR comma maybe I, which is nothing but indexes for I in range of this one. And maybe I can try to close a bracket. So this is our variance inflation factor for each and every column I will be able to create. This is nothing but I'm just trying to do for each kind of a loop. I think we all are aware about a for each kind of a loop over here. So fine, we all are aware about this one. And maybe I can try to store this information inside uh, some other data frame. So maybe a VIF underscore DF. So I can try to store that information inside that particular data frame. Possible, right? So VIF underscore data frame, and maybe we can try to create a column called as VIF over here. Fine. But before that, so I'll have to create a VIF data frame. So let's try to create a VIF data frame. A blank data frame we can try to create. VIF underscore DF is equals to pandas dot data frame, right? VIF. Okay, so VIF data frame. As of now, okay, and maybe we can try to give VIF of feature is equals to, what is my data frame name? Okay, it was X. Again, I have written VID. VIF, sorry, VIF for feature. This is one of the column, this is another column. Okay, yeah. So fine. So this is a VIF that we are able to receive for each and every columns, right? So for GRE score, what is a VIF? For TOEFL score, what is a VIF? For a university rating, what is a VIF? For SOP, LOR, CGPA, and research, what is a VIF, right? So here, can I say that VIF score for each and every column is lesser than 10? Yes. So it's a lesser than 10. VIF score of each and everything is lesser than 10. So can I say that I'm not supposed to drop any columns over here, or maybe I'm not supposed to call demonstrated reduction technique over here, PCA or TSNE in this particular place? Yes. So can I say that we can try to use this data set that we have been using as it is, array data set that we have created? Yes. Okay. So where did I miss? I have 8 columns. So I think you have not removed your very first column, which was a serial number. Just try to check that particular part. Okay. So here we are able to make sure that, okay, there is no multicollinearity that we have in between. And as per our studies discussion about a VIF, so yes, we are able to validate that this is how we can create a VIF. Simple, call a VIF, try to import a VIF, and then try to pass your data as well as column number, and it will be able to do that. So now once we are able to perform this kind of operation, so once we are able to perform this sort of operation, so maybe our data set is good. So maybe a data set that we have been using is good now for a different kind of operations that we can try to use, or operations that we can try to perform. So fine, I think now we can try to utilize this entire data set, or we can try to use this entire array for our experiment or next operations that we already have. So here, whenever we try to build a model, right? So we try to split a mod, or we try to split a data set into two set in general. Again, it's not hard and fast that you are always supposed to split a data set into two different area, or maybe one different area. It's possible that yes, we may try to split a data set, and then after that, so maybe we can try to perform a different kind of operation. So that particular split is called as train and test split. It's a norm, right? So we can try to split our data set into a training data set as well as testing data set. So with a training data set, so I'll try to do just a training, and with respect to a testing data set, so maybe I can try to test or verify a model. So why we are doing this train or test kind of a split? So we are trying to do this train or test kind of a split so that I will be able to, right? So I'm just trying to do this train and test kind of a split because I will be able to perform maybe testing operations on top of an unknown data set, because training data set is a data set which my model has already seen, right? Or my model has already adjusted itself. So if I'm going to test my model with a training data set itself, it's not a good idea. So that's the reason. So we always try to keep some of the data set which we can use to validate my particular model, right? So that's the reason. So I have done an import for train and test split. So if you will see over here, right? So I'm trying to do train and test split over here. I'm just trying to import, try to utilize that particular import, and then let's try to perform this train and test split over here. So maybe I can try to do a train and test split in this particular place, and we can try to pass our array, a data set that we have created after scaling our data set, right? And over here, so we can try to give corresponding y, and then maybe we can try to give what, test underscore size. We can try to give over here. Now test size, we can try to keep it as maybe a 80% is to 20% ratio, right? So 20% will be my testing data set, 80% will be my training data set, or whatever ratio I would like to take. So maybe I can take it. So this is just a hyperparameter. So there is no hard and fast rule that you are just supposed to use only this much for the training or that much for the testing purposes. So we can try to use any of these things. So fine, no issue. So maybe I can try to keep initially as 0.25, 25% for my testing purpose, and 75% of my data set for a training purpose. There is a possibility. Now, so I can try to execute it, and it is going to give me a 4 data or 4 outcome or 4 tuples. It is going to give it to me in general. So one, see, if you will start looking into a data set, so it is going to give you a exact 4 tuples, right? So once 4 tuples, it is going to give it to you. Now what are those tuples, or what are the data set that it is going to give you? So let's try to understand. So maybe we can try to store this particular data set into, right? So into x underscore train, comma, x underscore test, comma, y underscore train, comma, y underscore test, right? Execute. So here, now we have divided our data set into training. So x train, y train, x test, y test. So testing data set I will be using at the time of testing. So once I will end up building a model, and then training data set I will be using at the time of training. Now here, so if I'll try to recall just my train data set, right? So let's execute and execute again, execute and execute again. So can I say that my data set is changing again and again? Yes, my data set is changing, right? Because by default, it is going to split a data set on a random fashion, right? On a random fashion. So it will keep on like splitting your data set. So in NumPy, I think we have seen one of the function, right? In NumPy, we have seen a function, so which can try to fix a randomness. Means it is going to do a selection, random selection, but that will be a fixed random selection. Yes. So I think that particular function's name was, or that particular operation's name was seed, right? Seed. So here in train and test split, you will be able to see exact similar kind of a function, or you will be able to see exact similar kind of a parameter, and that is something called as random state. Random underscore state. So again, let's suppose if I'm giving a random state is equal to 345, let's suppose, right? So random state, and even if you are giving a random state is equal to 345, so for you as well as for me, right, this split of the data set is going to be same. Any random set, just like a seed, right? Just exactly like a seed. So now if I'm going to execute again and again, so is it changing now? Yes or no? No, it's not changing, right? So fine, I just fixed the randomness. So again and again, it will not try to choose or like try to select some of the random data set. So now even you can do the same kind of a things, right? Exact same thing you can try to perform over here. So now once I'm able to create my training data set and my testing data set over here, so maybe I can try to call what? So I can try to call algorithm. So what is algorithm I'm supposed to call? So I'm supposed to call maybe a linear regression over here. Linear regression over here I'm supposed to call. And maybe I can try to create an object. LR is an object of a linear regression. I'm supposed to like create an LR dot. What I'm supposed to call, guys? So fit, I think we all have studied, right? So fit we are supposed to call, and what we are supposed to pass. So can I say that x underscore train, so this is my feature, and y underscore train, this is my label, is something which I'm supposed to provide. So once I'll do that, right? So can I say that just within a fraction of second, it is able to build a model? Again, if your data side is like a very, very huge, just a 500 number of records, if I have a 500 millions numbers of record, it is going to take some time, right? But here in this case, so yes, easily it is able to build this particular model. So maybe we can try to dump this model, right? So maybe we can try to store this particular model, because this LR is what? LR is a model. Agree everyone? I think this is the second time we are trying to build a model, right? In this fashion. Yeah. So this is the only part where we are trying to build a model. What happens inside this model building? I think we all are aware about it, right? Bit by bit, piece by piece manner. So we all are aware about it, each and everything, including a whole mathematics, like what happens when we call this part, right? So we all are completely aware about it. So maybe if I would like to like store this model, let's suppose in a directory, right? So in certain directory, I would like to like store this particular model. So maybe we can try to call what? So maybe we can try to store it. So maybe we can try to create one of the file over here, and then we can try to dump it. So pickle dot dump, right? Pickle dot dump. And then what we are supposed to dump? LR model that we have created, that is something that we have to dump. So for that, we are supposed to open up maybe some of the files. So I can try to like open up some of the files over here. So maybe I can try to give a name, admission underscore LR model, right? Dot pickle, 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 right? So maybe I can try to dump this entire model physically. I would like to like store this particular model, right? So fine. So it has created a physical model over here. So if I'm going to do maybe yes, so somewhere in this directory, you will be able to find out this model. Somewhere it has created it. Yeah, so can I say that this model is created? Yes, so this model is created. A pickle file is created for me. So you can create a model in a SAV format, in a pickle format, going forward in a TF format, in a TF Lite format, in a PYC PyTorch format. So there are many different kind of formats which is available. All of these things are nothing but just a file format, right? A binary format or a serialized binary format, we say in general, or maybe into a H5 format. So there are so many different formats which is available. You can try to use any of these, right? So you can try to use any of these, and it will be fine. Yeah. So yes, we are able to store this particular model. I can try to maybe do some sort of a prediction, right? So I can try to do some sort of a prediction. There is also a possibility, just with respect to what? Just with respect to this model. In both the way, I can load a physical model and then I can do a prediction, and I can try to do a prediction even from here. So even from a model part, this is a model object, right? So predict, I can pass a data, right? Okay, so let's try to do a prediction. Now, before doing a prediction, so I would like to recall my data frame. So there was like a GRE score, TOEFL score. These are the inputs which we are supposed to give. Okay. So I would like to like do some sort of a prediction. So let's suppose if I'm like looking for a prediction of this particular data set, right? So maybe I can try to give a record. So I'm supposed to give what? I'm supposed to give GRE score this, so that I will be able to do a prediction. Yeah. So fine. Let's try to give this as an input for doing a prediction. Yeah. Now score is 9.86. Yes, score is 9.86. What was my expectation, by the way? Yeah, 0 to 1, right? Chance of admit was available in between 0 to 1. So why we are getting this outcome, and what is wrong with my input? So if you remember, right, again, this concept is going to clarify many of your confusion. We always say that whatever you have done with your training data set, same thing you have to do with your testing data set. This is a saying. So can I say that we have standardized our data set, training data set? So we have changed a complete range of the data set. Yes, we all have changed a complete range of the data set. A scalar dot fit transform we have called, right? So we have changed a complete range of the data set. Yes. So here, when we are trying to give this particular data, so can I say that I'm supposed to use a same object to change my data set into a lower scale? Same, by using a same object. Again, you're not supposed to create a new object. Again, you will create a new object, it will fail. So can I say that by using a same object, same scalar object that we have created, right? So a scalar object that we have created, so we are supposed to call what this time? So maybe transform I'm supposed to call, and I'm supposed to pass this data, right? And I'm supposed to pass this data inside scalar transformations. Now this is a transformed scale. This is the data that we are supposed to provide. Yes. So this is the data that we are supposed to provide. So maybe I can try to take test underscore test one, right? So test one, let's suppose I'm trying to do. So this is a data which we are supposed to insert inside our model. It's not like direct data. So whenever you are creating a testing pipeline, whenever you are productionizing any of the data, right? So user will input this data by default, because user doesn't know that whether you have done some standard scaling or what you have done with respect to your model. User is not aware about it. Suppose if I'm a user, I'm using your web portal, so where I'm supposed to feed all the information. I'm not aware about like any of such kind of things, what you have done internally, right? I will try to feed what? I will try to feed only this data, right? As per my like understanding, because user is what, like user is someone who don't know about the implementation. So I will try to feed just this particular informations, what you are supposed to do from your side. So whenever user will feed that information, so whatever object of a standard scalar or whatever transformations you have done with respect to your data set, right? Going forward, this complexity is going to increase. Suppose if I'm taking a categorical data or some other set of a data, there are hundreds and thousands of variations you all will be able to see, right? Observe. So whatever things which I have done with respect to my testing training data set, same thing I have to do with my testing data set. Then only it is going to give you a correct result. Otherwise, you will end up getting a complete false result. Very simple. Yeah. Okay. So what I will do is, let's suppose if I'm trying to pass this data, right? This data. Now, can I say that this time I'm able to get some approximately close result? Yes. It's close, right? Yeah. So this time we are able to get a result. That's the reason. So last time we were getting an incorrect result. This is what happened generally. Like whatever at the time of training, so we try to implement 10 different approaches to convert or do a data transformation, but at the time of testing, we don't do it. And because of that, so we used to get a wrong result. So user is just like a layman, right? So he will just try to insert whatever data he wants. So you are supposed to handle it from your side in your testing pipeline. Okay. So yes, we are able to get a very close result, right? So it simply means that that model is able to learn something. Yeah. So maybe I can try to use some other data, and I can try to test it. Yeah. 0.80. Can I say it's close to 0.76? I was expecting 0.76. I got 0.80. Yes. Means approximate close result I'm able to see, approximate close result I'm able to observe over here. So it has understood some sort of a relations, right? Maybe by accuracy is 80%, 100%, 20%, whatever it is, but it is able to understand a concept. It is able to understand some sort of a relations that we had inside our data set. And yes, we are able to get a close result over here in terms of a prediction. Yeah. So fine, in the similar way, so this is the prediction which I'm able to do with respect to an object. So whatever physical file that I have created over here, so maybe with respect to that physical file, if I have to do some prediction, so again, I can do it, right? So what we can do, so maybe we can try to call a pickle dot load. So LOAD load, and what we are supposed to load. So maybe we can try to open up a file over here. And what is my file names? I think admission prediction dot pickle dot this one. Yeah, so we can try to call this particular part this one, comma, so maybe into a read mode we can try to open it up. Yeah, so this is my model, right? So maybe model is this one, right? So I'm just trying to read my model physical file, by the way, which is available in my system, not an object. And then same thing I'll do. So model dot what? So model dot predict, and nothing much. So same data I can try to provide, and I will be able to get my prediction. Yes. So it's the same result that I'm able to get. So whether it's an object or whether it's a stored file, so from where we have to do a testing, I can do it. Very simple. So this is something that I have stored. I can share this file with you, and you all will be able to do a testing. You're not supposed to like perform all the operations which I have done, right? Similarly, so the scalar model that we have created, even you can store that model, because scalar transformations that you have done, that is also a model. You have created a fit underscore transform, that is also a model. Yeah. So fine, this is something that we have already done. Now I'm supposed to know that what is a score of my model, or what is R square, because unless and until you are not going to tell me that, okay, this is your accuracy, right? I'll not even allow you to productionize my model. So let's suppose my expectation is 90% and your model is giving 80%. So in that case, I'll just ask you that, okay, so try to do some sort of improvement in your model and then try to productionize it, right? So at the end of the day, you are supposed to do that. Yeah. Okay. So how I will be able to check a score? Again, very simple. I think we all are aware about it. So linear regression, which is nothing but my model object, or maybe I can call even a model. Both are completely fine. Right. So linear dot what? So maybe we can try to call a score. And in terms of calculating a score, right? In terms of calculating a score, so we can try to give a data set that we have used for the training, but that is not a correct approach, because my model has already learned a pattern from some data set. So true score I will not be able to get. So if I'm looking for a true score, maybe I'll have to give some of the unknown data set which model has not seen yet, right? Some of the unknown data set I'm supposed to give. Now, what is my unknown data set? So can I say that we had created a test data set, right? Can I say that we had created a test data set? So X test and Y test, right? We have already split our data set. So 25% of the data set I have kept for the testing purpose, right? 25% of the data set I have kept it for the testing purpose. So maybe I can try to use this data set. So it will try to take this data set and it will try to give Y hat. Y is already available. So after giving this input, it will give me Y hat, and then I can try to do a comparison, right? Then I can try to do a comparison over here in this particular place. That is completely fine. So okay, no issue. So we can maybe do it. So here I can do one thing. Maybe I can try to like a LR dot score. So I can try to give maybe X test, and then I can try to give maybe a Y test over here. And what is my testing accuracy, or what is the accuracy of my model, or what is my R square? So can I say that R square is nothing but it's a score? Or a score is nothing but it's R square, right? So let's suppose if I have to if I have to calculate maybe adjusted R square, then how I will be able to calculate adjusted R square? Yeah. Okay, so maybe I can try to create my own function for adjusted R square. So can I say that this is the same formula that we have discussed yesterday? Yes, this is the same formula that we have discussed yesterday, right? Adjusted R square. Yes. So maybe here what I can do is, so I can try to call LR. LR is my the model. So LR dot score x2, and I can try to call ADJ R2. I can try to give x underscore test and then y underscore. It's just a manual function. So what is my adjusted R square? 73.25. What is my R square? 74.76. Adjusted R square is a little bit lesser than R square. So this is my actual accuracy. 73.25 is my actual accuracy. Yes. So this is something that we are trying to call over here. Now, so if I have to increase an accuracy by a little bit, so maybe I can try to change in my random state. So let's suppose if I'm going to use random state is equal to 100, let's see whether it is going to impact my accuracy or not. So can I say that I have just changed my random score from 345, I believe, to 100, and my score has changed? Yes, my score has changed, right? So my R square is approximately close to 82.62, and my adjusted R square is 81.58, right? So let me ping you this adjusted R square code. It's the same thing, like just a function. So whatever we have discussed yesterday, based out of that, that is a function, right? So like we have discussed. So on which what is the true score which I'm supposed to accept? R square or adjusted R square? Yes. Can I say that I'm able to increase accuracy? Last time, what was the accuracy? I think 73, 74%, right? This time, what is the accuracy? 81, 82, right? So how this happened? Okay, so I think you have taken a nap for maybe a fraction of a second. I have changed just one parameter over here, random state. Previously, my random state was 345. This time, so it's 100. Again, I have just taken a random one, right? Okay. Now here, maybe I can try to keep it as 0.15. So training will be 0.85 and testing will be 0.15. So for more data, I'm trying to give for the training purpose. Can I say that my score has increased? Again, a little bit. Yes. So I'm just trying to make some sort of a changes. Now those changes are not hard and fast, right? It's not like someone will tell you that this is the number that you are supposed to give and you will be able to increase the accuracy or decrease the accuracy. No, it's a experimental one, a very simple thing. It's an experimental one. You are supposed to experiment, and then out of the experiment you will be able to get it. What if you will not random dot seed, then again, so every time you will be able to get a different kind of accuracy, because every selection of the data set will be different, random selection, so different accuracy you will be able to get by default, right? So ऐसा करते करते accuracy 100 पर ले जाओ, no, not possible. See, there will be a limitation with the relationship of the data set, right? So like it's not like 100% you will be able to achieve, but yeah, so we are able to improvise certain set of the accuracy over here. Yeah, I know it's people was joking. Excuse me. Yeah, so I think we are good till this point. Yes, so we are able to increase our accuracy a little bit, and yeah, so we are like able to build a model, store the things, and standard scaling, train test split, all those things we have already implemented. Yeah. Okay. Now, so it's like completely fine. Now if you will check, let's suppose if I'm giving this data, right? So what is a prediction? So let's suppose this is the test data. So if I'm like looking for a prediction, it will be 80%. Yeah, so 76, 80. Okay. So this is the accuracy that I'm able to get in this particular place, which is like completely fine. Now, what we can do next? So if I would like to know that what is actual equation that model has built, so how I can know about it? Let's suppose I'm looking for actual equation. So how I will be able to get the equation? Yeah. So can I say that maybe we can try to call LR dot coefficient, right? And what? So LR dot, can I say that intercept? Now, can I say you all will be able to write the equation? Yes, we all can write an equation. Now, if I'll ask you, okay, fine. So can you please do a manual calculation on top of the data set? You can do that. Yes. Okay, fine. So R square, adjusted R square, what is the equation? What is the C value? Everything is very, very clear over here, right? Okay. Now, yesterday we were talking about we were talking about a regularization, right? So I think we talked about a lasso, we talked about a wrist, we talked about a elastic net, right? So when we are talking about a lasso, so it always try to do what? So it will always try to, it was a lambda summation of mod of m or mod of beta, which was written, right? Mod of m. And if I'm talking about wrist, so it was nothing but a square, right? So lambda of like a summation of m square. And if I'm talking about elastic net, so it's nothing but it's a combination of both. Alpha is a like external factor which was given to me. So maybe we can try to use a wrist, or maybe we can try to use a lasso, and based out of that, yes, so maybe based out of that, so maybe we can try to see, or we can try to check that whether I will be able to build a best or better stable model or not, as per our discussion, because that's the reason. So we have discussed about a regularization, and I think we all are aware about what is the actual meaning of regularization and what happens when we try to implement a regularization. So yes, let's try to understand this regulation part, why we are talking a calculation for regularization. I think you should attend previous classes. Yesterday I have talked about it for 2 hours, that why this is required. Okay. Now, so what we can do is, so maybe we can try to implement a raised or maybe a lasso. So if you remember, I have done an import for lasso CV. This is nothing but it's called as lasso cross validation. And here, so you will be able to find out a different kind of a parameter. So you will be able to find out EPS and alpha, fit intercept, maximum iterations, tool, copy X, many things you will be able to find out, right? Now here, so let's try to understand this part, that how I can try to implement this different kind of a thing. So lasso CV, I'm trying to call it over here. I'll try to talk about a CB. What is the actual meaning of a CV? Maximum iteration is equals to maybe 2 lakh. I can try to give. Normalize is equals to true, right? True. And let's try to understand. So maybe lasso CV is a variable, and lasso CV dot, I can try to call fit x underscore train, I can try to call, and y underscore train I can try to call. Lasso CV has no object called fit. Okay, it should be fit. Yes. Okay. So here is data. So here is things that we all are able to see, or we all are able to get. Now, so maybe we can try to call lasso CV dot alpha. Yeah, so this is something that we all are able to get. Lasso CV dot alpha is this much that we are able to see, right? And then we can try to create a lasso object, just like a linear regression object that we have created over here. So LASSO lasso, and then we can try to put alpha over here. alpha is equals to, you can try to write it down over here, lasso dot fit. We can try to call in this particular place, we can try to give x underscore like a train and y underscore train. Yeah, so this is like a done. And now here, so if I'm going to give lasso dot score x underscore like a test and x underscore, sorry, y underscore test. Now it is giving me accuracy is equal to 84.21%, right? So here I have just done an implementation for a lasso. Maybe I can try to increase iteration more. So in this case, no effect. Cross validation is equals to 5. I can try to implement 84%. And maybe I can try to implement alphas. So initially alphas is equals to none. Yeah, 84.21. So every time I'm able to get 84.21, this is the accuracy. Now here again, I know many of you are not able to understand this particular part. So this is again a model, a linear regression model that we have built over here, same. But here, so we are trying to use what? So we are actually trying to use a lasso. We are not trying to use in this particular place. So we are not trying to use a simple plain linear regression. So we are trying to use a lasso, linear regression with a lasso. So this is what happens over here. But before that, what we have done, so we are supposed to find out a value of alpha or lambda that we have discussed yesterday, right? What is a optimal value of a lambda that I will be able to get, or I will be able to see. So this is what I was supposed to find out in a very first place, because lambda is what? It's just a known variable. So it's not like I can take any value of the lambda. And that is a reason. So we have done what? So we have done a cross validation over here. Now, what is the meaning of this cross validation, right? So let's try to understand what is the meaning of this cross validation. And here, so when I have written cross validation is equal to 5, so what will happen at that point of a time? So here, this is a technique. This is a technique to find out a best possible parameter. This is a technique. Cross validation, CV is nothing but it's called as cross validation. It's a technique to find out a best possible parameter by doing a random experiment. How and what kind of a random experiment? So here, if we have written cross validation is equal to 5, over here, what will happen? Let's try to understand. So let me share my screen. So let me share my whiteboard for now. So here, what will happen is, I think my whiteboard is visible, right, to everyone? Yes. Okay. So here, when I have written CV is equal to, and it's visible, right? But whatever I'm writing. Yeah. Okay. Okay. No, not visible. Okay. So now I think it will, is it visible now? CV I have written over here. Yeah. Okay. So fine. Cross validation simply means that if CV is equal to 5, what it will do is, so it will try to divide my entire data set, whatever data set which I'm giving, whether it's a train or test or whole data set I'm trying to give, it will divide my data set into 10, sorry, 5 I have written, right? So 1, 2, 3, 4, 5 set. And if you remember, so maximum number of iteration is equal to 2 lakh or 20 lakh is something which I'm trying to give, right? So maximum number of iterations. So what will happen is in iteration number one, so when it is trying to like find out the best possible parameter, or best possible alpha parameter, it is trying to find out. So what it will do is, so it will try to treat this first, let's suppose 4 set of a data for training purpose, then training testing purpose. In second iteration, so again any 4 set of the data set for the training, and then 1 set of the data set, some of the data set for the testing purpose. So in this way, every time it will keep on rotating your data set again and again and again, and then out of that it will try to find out a best possible parameter. That is something called as parameter, or best parameter finding, or that is something called as cross validation. So in cross validation, we always try to divide our data set into a multiple sets, a multiple chunk, right? Maybe in 10 set, 20 set, 100 set, whatever we want. So we can try to divide so that every data set will be having a different like variations and variance into this one, into itself. And then it will try to give all data set for training, and then one it will keep for the testing. So it will test, try to check that what is the accuracy, and then again it will try to test it with the, or train it with the another random set of the data. So this is what happens in general in case of a cross validation. Cross validation is a widely used technique almost in every application or in every algorithm. So we are going to use it to find out the best possible parameter. Every time we are going to use it. So this is something that we are trying to use. Maximum validation normalized is equal to true. So just try to normalize the entire data set, although my data set was normalized, but still on top of that, just for the additional effect. So we are trying to use it. So we can try to give any numbers over here, any number of the maximum iterations over here. Okay, so now it is going to fail. It's too long for a Python. Again, too long. Okay, now it's fine. Yeah. Okay. So here it is like trying to iterate or pass again and again a data set, right? A 5 set of the data set. Maybe I can try to divide this data set into a 50 set, and in a 50 set, so it will try to perform those kind of operations. So 49 set at a time it will try to take for a training purpose, 1 set it will try to take for the testing purpose, right? Randomly, in a random fashion. So this is what it means. So cross validation we are going to use heavily in case of our hyperparameter tuning of the model going forward. So even over here, so we are trying to find out what? A hyperparameter. Nothing else we are trying to find out except a hyperparameter inside our model. So that is like fine and pretty much normal for all of us. And so here I'm trying to find out the value of alpha. Same value of alpha I'm trying to use at the time of training purposes of a lasso. Lasso is nothing but, again, it's equivalent to my linear regression that we have used, right? So that we have already used, and this is the accuracy which I'm able to get. Now next step what we can do is, so maybe we can try to use RISD regression, right? So if you remember, even in case of a RISD, we are supposed to find out what? So we are supposed to find out the best possible alpha values, right? So best possible alpha values I'm supposed to find out. So maybe I can try to use a RISD CV. So RISD CV is an import that we have done. Alphas is equals to initially none. Maybe we can try to keep, right? Maybe we can try to keep none over here. Cross validation. So in how many sets we are supposed to divide the data set? Maybe a 10. Normalized is equals to true. So yes, normalize my data set, right? So this is a RISD CV. RISD CV object I have created. And once after creating this RISD CV object, what we can do is, so maybe we can try to call RISD CV over here. RISD CV dot fit and xtrain comma y underscore train. I can try to call. What happened? Again, I have written FIT. Now what happened? Length of unsized object. Okay, type error, length of unsized object Fine, so we can try to maybe give some sort of a size over here. So out of this, okay, so this CV dot. So 0.1 is a alpha that we are able to get, but I'm not sure whether this alpha, because this is the only selection that we have given. This is the only range. We are saying that okay, out of this 3 alpha, try to select, right? So out of this 3 alpha, try to select some of the alpha. This is what we are trying to say over here. Is alpha and lambda the same thing? Yes, in theory. So we talked about a lambda. In scikit-learn library, it's denoted as alpha. Simple. So here what we can try to do is, so maybe we can try to give a wider range of alpha, because this is the hyperparameter. So we are trying to select a best possible alpha. So just try to give a higher range of the alpha so that it will be able to find out a best possible one. So if we have to give a higher range of alpha, so maybe I can try to use numpy.random.rand function or uniform function, and then out of that we can try to create it, right? So numpy dot random dot maybe uniform, and then we can try to create some sort of a data set in between, maybe starting from 0, go till somewhere 10, right? And maybe generate 50 such records. So these are the 50 numbers that we have generated between 0 to 10, right? So maybe we can try to give this data over here. So maybe we can try to give this data. So this time alpha is equal to 0.38. So after doing some sort of experiments, so out of this many number of alpha, it is able to finalize this alpha as a final one. No issue. I can try to test it with the RISD over here. So we can try to create a RISD object and with alpha, right? So alpha is equal to this one, RISD alpha. This is the object. So RISD LR, linear regression. I have given this object as a name, and then we can try to call RISD LR dot maybe a fit over here, and maybe X train I can try to give X train comma Y train I can try to give over here, and this like a model is done, model is built. Maybe we can try to do some sort of a testing with this one just to check what is the score of this model. So I can try to type train and test and Y underscore maybe test over here. Now what is the accuracy? Accuracy is 84.20. Last time accuracy was 84.21. So with RISD, we are able to get accuracy is equals to 84.20. With lasso, we are able to get accuracy is equal to 84.21. Without RISD or lasso, with a simple linear regression, right? So what is the accuracy that we are able to receive? So what was the accuracy, by the way, guys? Anyone who remembers? 80.28, somewhere around 8081, right? So somewhere around 8081 is something that we were able to get. So can I say that with RISD and lasso we are able to get a best possible model? Yeah, 84 point, like close to 84 point something. Okay, no issue. So this is the model accuracy. Maybe I can try to call elastic net as well, right? So let's try to experiment these things with the elastic net. So elastic, which is a combination of RISD as well as lasso, right? So even for this one, so we have to find out the alpha. Initially, I can try to keep it as none. Cross validation is equals to 10. I can try to keep an elastic. Okay, and then we can try to call what? Elastic dot, I can try to call fit over here, X underscore train I can try to write, and Y underscore train I can try to write. Yes, and this is a elastic. So maybe I can try to call elastic dot alpha. Yeah. So for elastic, so what is the alpha? So alpha is this one. And for elastic, so if you remember, lambda and alpha, both the things are required. Two things is required, right? Ratio. So L1 ratio is required. So what is the L1 ratio? What is the L2 ratio, which is required, which was nothing but denoted by alpha in our theory classes. So here, whatever I'm saying as a alpha, it's actually a lambda. And yesterday, whatever I have discussed as a alpha, that is basically a L1 ratio. So what will be the ratio for like alpha or this one? So no issue. Elastic alpha. So elastic dot, maybe we can try to call L1 ratio. So what is my L1 ratio? What will be the effect of L1? So approximately close to 0.5. No issue. So now let's try to build a model. So elastic net. So alpha, what is my alpha by the way? So alpha is equals to this much, right? And then maybe I can try to call L1 ratio. So L1 ratio is nothing but it's going to be this one. This is the L1 ratio. Elastic underscore LR. Yes. And elastic underscore LR dot fit. And then we can try to call what? So X underscore train, Y underscore train, execute. And then let's try to understand its accuracy. So score is equals to what? So my score is X underscore test, I believe, and Y underscore test. Yeah. So 84.19, approximately close to like wrist, lasso, and elastic. All three is giving me almost a same accuracy. So can I say that like by using this one, so my, and again, if by building a model, so if I'm able to get a same accuracy, right? So my model is a stable model. Whatever model which I have built is a stable model, because even out of alpha and elastic, sorry, out of lasso, raised and elastic, so I'm able to get a similar kind of a things. Yes. So can I say that whatever model that I have built is not giving me any kind of overfitted result, right? So this is just for the verifications. This is something that we have done is just for the verification, nothing else. So is this things clear to everyone? Can adjusted R square even be more than R square value? No, in ideal cases, it won't be a case where it is going to be more than R square values, unless and until you are not doing some mistake. It is difficult to code along. What was your question? To code along and understand what you are saying. Could you please explain a little slowly? See, that's the reason. So first of all, I have given you a theory classes. I told you what is elastic, what is lasso, what is wrist, what is a mathematical intuition behind that one. If you will watch today's recording, right? If you have not attended it, and then I'm talking about it. And at the end of the today's class, I told very clearly that before coming for today's class, you have to go through it. So whatever I have discussed theoretically, so that you all will be able to understand an implementation very easily. Code is nothing, I'll say. So what I've written in code, same thing again and again, just like a linear regression I was trying to use. So in the similar manner, I'm just trying to use elastic net object or lasso object or rigid object. So can I say that that same model we are trying to build in actually 4 ways? One by using linear regression, one by using lasso, one by using REST, one by using elastic net, right? Can I say that fourth, like same work we are trying to do by a 4 approach? Agree, everyone? Yes. A coding is nothing. It's just a typing practice. That's it. This is what I understand as a coding. So do we need a rigid and lasso when our model is not overfitting? So no, this is just for a verification, right? So I've just verified it that, okay, so like whatever model that I have built, it's a stable model, and I have verified it in all 3 ways. Used to verify the model accuracy? No, you can productionize it as well. So you can convert, or you can create a pickle file out of this one, and then you can productionize it. That is also possible. If we give a large value of maximum iteration, training size also increase, which steps up to get a higher accuracy. No, it will not steps up to give you higher accuracy if you don't have much amount of a data. Let's suppose if error is equal to 0, again and again and again and again, error is equal to 0 is coming, or difference between y and y hat is equal to 0. In that case, there is no meaning of giving a maximum iterations is equal to 1 lakh or 2 lakh. If you have a huge amount of data, then it makes sense. Otherwise, you are just exhausting your computation resources. So it is not going to help you out. I'm getting 82% accuracy in all the model. Why so? You can try to test it. You have a hyperparameter, right? Train test size or random state you have. Again, alpha range. So you can just try to experiment it and then you will be able to see. Is this the maximum accuracy we get? Maybe you will be able to get some better accuracy than me. I've even used a random number. Like I said, it's all experimental things. No one can tell you what will be the number or what is the accuracy, that final accuracy you will be able to get. What is L1 ratio? So in my studies class, I was talking about lambda and alpha in elastic. Right, guys? How many of you remember? I talked about two factors, lambda and alpha. Yes, in my studies elastic net class. Yes, people remember. People like remembers it. So here L1 ratio is nothing but your actual alpha, and your lambda is alpha here. Why we are calling R2 R square accuracy? Yeah, because I just wanted to test it. So I can use R square or adjusted R square. So you are feel free to use adjusted R square. No one is going to stop you, right? So who is stopping you to use like a adjusted R square? I clearly said that you can use adjusted R square. Adjusted R square is better as compared to R square when number of the columns and number of the rows are going to increase, right? Because there is a dependency which has been created in adjusted R square with respect to a number of columns and number of rows by using NNP as a factor, right? You can use it. Simple. So in a denominator, there is a n minus 1. In numerator, there is 1 minus n minus 1. In denominator, there is n minus p minus 1. Use any of these. Should we adjust R square be calculated on training data set, or both? If we should we follow? Yeah, you can adjust it. How to minimize the loss in this case? You are not minimizing a loss. You will be system or model or equation will be able to minimize a loss. You are just supposed to give a best possible parameter and maximum amount of a relevant data. So if you are going to give a maximum data, or if we are going instead of 500 column, 500 rows, not column, 500 rows, if I'm going to give maybe a 50,000, in that case, there is a chance. Again, there is not a hard and fast rule that you will be able to you will get some sort of an increment in your accuracy, right? There is a chances, because there is a saying in AI. So in real life, 1 plus 1 is equal to 2. In AI, 1 plus 1 is not equal to 2. 1 plus 1 can be anything in AI because it just understands a relation. So if I'm like using maybe a multiplication relation, things will be different. Division, things will be different. And if I'm trying to use subtraction, things will be different in the same thing, right? So in AI, 1 plus 1 is never going to be 2. So if you're going to add some more data, so if data variance is different, so the added data or the next data set that you have added, in that case, your accuracy may go down. That is also a possibility. But if you are going to give a relevant data with the same distribution, with the same variances, there is a chance that it will try to increase or adjust a parameter in a better way. Because we all have learned, right, in our theory classes, even mathematically, it's all about finding out a best possible relations by finding out a known parameter of a equation. That's it. Is there any geometric intuition for raised and lasso like LR? I think you are not able to understand then raised lasso and elastic. You're not able to understand at all. That's the reason you are asking this question. The problem over here is same LR that we are trying to build, same linear regression that we are trying to build. The only thing is where we are calculating a error function. So we are trying to decrease a degree of freedom of changes, any kind of a changes which happens in M. So at the end of the day, we are actually trying to control M, which is responsible for drawing your line. So try to understand in that way. I think I have explained you each and everything, right? So just try to think in that way. Could you please address this question? I think I'm addressing almost all the questions. If your question is unique, I will address. Otherwise, I'll leave. Can you see my queries? Yes, David, I can see everyone's queries. And I think I have already answered. Everyone is just asking same question multiple times. Why accuracy changes while changing a random state? First of all, try to understand what is the meaning of random state. I told you it's equivalent to a seed. So just trying to choose a different set of the data, different random combinations of the data. So if you're using a different random combination of the data, for sure, this is something which is going to happen. Which is best, lasso, ridged, or elastic? None. It's an experimental thing. Mx plus c is base in ml. No, who told you? This is just one of the equation. Already there is alpha y L1 ratio in the parameter. Try to go back to your studies class. 10 times I have said the same thing about alpha and about a lambda, right? Many of you are able to understand, some of you are not able to understand. Try to understand whatever I have discussed in today's class. It was a very, very important class that I have taken yesterday for your batch. Last unit is also used for overcome overfitting. Yeah, you can say that. Could you pass the dataset link, please? I missed the initial 20 minutes. It will be uploaded inside your dashboard. Don't worry. So by tonight, you can use it from there. Right, it will be available inside your dashboard. What type of problem statement we use linear regression? Okay, that's an amazing question. I'm not expecting this kind of a question after having a discussion. I think I have given you even some sort of assignments, right? I asked you to do that. Okay. Ratio is a mixing parameter, right? Yes. Lasso regression algorithm and this lasso are different. How this is different, by the way? Can you give one task for us in linear regression? Have you done, David, a last task which I have given to you? Have you done a submission? Okay, so fine. Now, the thing is, I think last time I have given you a question, right? And many of you have done submissions for the same thing, right? So what is realization? Okay, that's amazing question. So I think you have not attended a class yesterday, right? Please go and attend the classes. I have already answered whatever question that you are asking, guys, right? I can see it, and I clearly say that everything is discussed. Nothing is left from my side, at least. So please try to go through a class. And giving you a class, that doesn't mean that I'll just talk about the same thing more than 20 times in the same classes. Because when I give a lecture, I'm always taking a huge amount of time, which I can discuss just in 10 to 15 minutes. But I'm spending like a 2 hour of time for the same topic. Okay, so now the task for all of you is that whatever things which I have given to you in your last classes. So with respect to a data set, I asked you to do some sort of experiment and just try to build a very basic linear regression model. Now you have to do one thing. So whatever discussions that we have done, whatever regression technique that we have used, whatever feature selection technique that we have used, whatever model building approach that we have used. So you are supposed to create each and everything, and you have to submit a Heroku link. So you have to do a deployment. I think in Python, we have already discussed about the deployment, right? I'll teach you deployment even over here, right? But what I believe is I have already discussed about the deployment in your Python module. And I will try to talk about a deployment in AWS, Azure, as well as in GCP, all three, right? So your task number one is deploy. I'm leaving up to you if you can deploy in all four platforms. Well and good. If you are not able to deploy in all the 4 platform, right, at least I'm expecting you to deploy it in a Heroku. This is a first task number 1, right? You can take your time, you can create a very small pages, and then you can try to deploy it. I don't have any kind of a issue. Even without creating a pages, if you are going to deploy, I don't have any kind of a issue even over there. But yes, so you are supposed to create an API through which I will be able to test your model, right? So deployment is very, very important, right? And again, so if you are trying to use some sort of a standard scalar technique, so you are supposed to implement even a standard scalar technique and all those things over there. And all the coding guidelines you all are supposed to implement. So without a coding guidelines, so this task will not be accepted. For any data set, no. I'm talking about your previous task. So if you will go back to your previous class lecture, I think last Saturday, or when I have given a task, I think last Sunday, right? Yeah. So last Sunday class, if you will go and check, so I have already given you one task. So again, this is like a subset of the same task which I have already given you, and many of you have already done a submission. I have already replied back to you over your mail. So hope you have received that mail from my side, comment wise, right? So you are supposed to use a exact same thing. You are supposed to deploy this time by using all these things, like with respect to rigid, lasso, elastic, with respect to each and everything, you are supposed to perform these kind of operations. In your deployment, I'm expecting a pandas profiling result as well, right? So I'm expecting some sort of a button where I will click, I will be able to get a result. So maybe you can try to store a pandas profiling result in a HTML page and then host that HTML page over there. I don't have any kind of a issue. On the fly, on the run, you are not supposed to do this kind of execution because you'll have to keep a data set somewhere. So we all know how to render a HTML page for a pandas profiling, right? So you are supposed to perform these things. Yeah, Raksha Bandhan day task was given. Yes, I believe on last Sunday. So I have assigned you this particular task. In PyCharm, right? Why you are even asking this kind of a question now? So PyCharm, like after 6 months, if people are asking this kind of a question, right? Then what you are doing since last 6 months? Yes. I know you have already taught a deployment, but could you please show one deployment in any one platform? Yeah, I'll show you a back-to-back deployment. So again, this time we will not spend that much of time because we have already spent enough amount of time when we were trying to do a deployment in a Python. So deployment will be shown to you with respect to the same of things which I'm showing you. You have to do a deployment with respect to a task which I have given you with respect to UCI dataset. I will show you a deployment with respect to this admission prediction dataset, right? So we both have our own individual task, but in a quickest possible way, I'll show you a deployment. So I think it will take not more than 2 hours of time to showcase all the 4 mode of deployment for me at least. Yeah, but again and again, don't expect these things from us, right? It's a kind of a repetitive task. If you are not able to do it, then what you are doing? Simple. I want to understand this thing, something I can do deployment. I will cover. So I think you should, those who are not aware about it, those who are new to this class, so maybe you should start attending all the lectures which we have already taken. Then only you will be in a comfortable phase. Otherwise, it will create a little bit of issue for you, right? Just spend 2 or 3 weeks of time. That will be my advice. Bhavya. So I think you got to answer. Follow your deployment, integrate a pandas profiling result. Yes, yeah. So this is a task that you all have to complete. So let me ping you this task. Please give 2 days time. No, you have a complete week of time. So you can take a complete week of time. I don't have any issue. So this is not a 2 hour of task I'm giving you. You can take a complete week of time. You can create a beautiful one, right? So you can try to integrate as many functionalities as possible. You can even think about it from your side, right? And then try to perform some sort of operations, try to think about some of the model improvement strategies, try to do a better version of EDA, try to build a best possible stable model, try to showcase each and every parameter matrices and accuracies. So so I have given you this small task, right? but there are a huge possibility that we can try to showcase thousands of things, right? Try to showcase all those things. That will be fun, right? So that will be like a fun, and I think you all can do it, right? How many maximum number of columns can be there? 1,000, 2,000, 1 lakh, infinity. Did I get a reply back? Plus plus Sunny plus plus Avni's. Anytime I give intensive update. Yeah, so your spoke has been assigned as like those guys, and even your like a mail is forwarded to them. So you have to like again, you can follow up with them. They will give you response. The previous homework data, zero column is zeros and one column not visible in the interaction. So yeah, try to handle it. Sai. So discuss it before. We can take any data set. No. Same data set which I have given you in last Sunday's class. Same homework you have to extend this time. Yes, so try to expose it as an API, and then, right? So yes, Atul. So and then, if you have a time, I have one more task for you, right? If you have a time, fine. So just do one thing. Try to create one single class, right? Try to create one single class. This is a small task I'm giving you. Try to create one single class, right? Like we were trying to import like a elastic or list or lasso. So someone has created a class, someone has written a method inside this one, right? So try to create one single class, and inside that, so one single class for what? So one single class try to create for a data processing, right? So let's suppose for a standard scaling means I'll give a data in a form of numpy array or a data frame, right? Try to understand this problem statement carefully, right? What I'm saying. So try to create a class where I can try to give, when I will create an object of a class, I'll try to give a data frame or maybe some sort of a numpy array. Automatically, it is supposed to check how many null values are there. If there is a null value, replace all those null values, right? So there will be a function. Try to automatically, it should be able to do a standard scaling, right? So at least 2 to 3 such kind of a functions it is supposed to implement on top of. So you are supposed to accommodate inside this class 2 to 3 function, a basic function I'm expecting. That is not a task, right? The task is try to productionize it on PyPy. So just try to productionize it, right, on a PyPy. So whenever you like do a pip install, right? So yeah, whenever you do a pip install, right? So whenever you do a pip install, so can I say that it is like trying to do some sort of imports and installation from your PyPy repository, right? So here you are supposed to experiment that how to productionize your own library for a general public. This is what I'm expecting, right? So you have to launch your own PyPy, right? So maybe from class name underscore something. So if someone is going to call that one, so in that case, automatically it should be installed inside my system, right? Where I can pass a data. It will be fun. So how many of you are going to attempt it? Or any question with respect to this one? These are the 2 tasks. मतलब आप मास्टर बना के छोड़ोगे. Yeah, so you are here, right? You are in my class. So in my class, this is what happens. Yes, are you able to get that question? Are you all able to understand the question part, right? So generally we do pip install matplotlib, pip install pandas, pip install this, pip install like scikit, pip install maybe I can say a Seaborn or something like some pip install Flask, pip install course. All those things we used to do, right? We all try to install. So automatically it will go to a PyPy repository, right? And from PyPy repository it will try to install, or maybe conda install this, that we used to do, right? So what I want you to do is that try to create one class, inside a class, some basic 2 or 3 functions, right? And host it over a PyPy. So that if I'll just like type your package name pipe in my system, right? So pip install your package name, I will be able to get all the details, and inside a pipe you can maintain a proper documentation where I can see what and all functions are available. Is it making sense to everyone? A real productionization of a code so that others can use. And believe me, it's just a one-time task. If you're able to do it for once, right? Next time, you will just keep on creating a libraries of your own to simplify your task, and others will be able to use it, right? So it's not that tough. Yes. PyPy is a fun accepted challenge. Yeah. So just start working on this. And don't take anyone's help. First of all, there are very few people who knows about it. So don't take anyone's help. Try to explore it by yourself. You will face some sort of a hurdles, but yeah, that's good. We all are supposed to face some sort of a hurdles. Then only we can learn and we can do it. Now we are going to do Python Seva. Yes, this is called as community Seva. Python Seva. So you should know, right? So whatever library that you are using, so how someone has created it and how someone has made these things available. And when you will go for an interview, and in your interview, you are going to say that go to PyPy, right? Because believe me, your interviewer, whoever is going to take your interview, right? Even interviewer, I can assure you that 99.99% is a chance that your interviewer has never ever dumped one single package or library on PyPy, right? So in your resume, intentionally, you have to mention that, okay, I have created a small library for process, like just to automate a machine learning process, and this is available over a PyPy. Go and see, go and check. And then you will see, right? Then you will see that what kind of an impression it is going to create, because a 99% chance, there is a 99.99% chance that your interviewer has never ever dumped even a single library on a PyPy or any such kind of a repo. Yes. And it's that's the kind of a state of the mind, I would say. So it's not that tough. It's just a state of the mind. Yeah. And like, so when we are learning something, when we are learning so much of things, so why to leave this small part, right? So why not just like do it? Yeah. So this is a 1 week of a task. I will be expecting a report, a mail, the way you guys have sent me a mail for a previous task, right? In the similar way. So I'm expecting when you will create a PyPy, give me a link, a proper like a proper link of the hosting, then I will be able to check it. That's the one thing. Second thing is, for a first number task, again, I'm not expecting your code. I'm not expecting anything else. I'm just expecting for both of this task, I'm expecting a final link. Simple. I'll click, I'll test. I will not even look into your code. Yeah, code wise, if you can, if you would like to like a send, you can send it. But I'm not interested in your code this time. I'm interested in your final link that you are going to give it to me. Will you show an example of deployment of for today's class data set in Heroku? Yeah, I will show you, but I think I've already shown you a deployment in Python as well. So this time I'm expecting something from your side. I want you to work. Interviewer may be alumni of Intern. Yeah, in that case, yes. How we can dump our library to PyPy. So if I'm going to teach you each and everything, then what you will do? So what you will explore, right? In my class, people gets a challenge and they do it. Simple. If I have to teach you everything, then I will not even take like a 10 minute of time. I can do it like a, one single flow, but I want you to do it. Wait and watch, sir. Okay. So yeah, that's enthusiasm we are expecting, and let's do it by next week. So those two tasks is clear, right? Everyone is supposed to participate. Whether you are going to fail or pass, doesn't matter. You are going to do it or you're not going to do it. I don't care about it. I just care about the attempt, that whether you are trying to attempt it or not, right? Simple. So attempt is important. Okay, with that, so I'm done for today's class. So let's like see how many of you are able to clear it. In case of any concern queries, yes, please drop me a mail at query@find.ai. I think you all know the place, right? You have a doubt session as well. In case of any kind of a concerns, feedback, you can drop me a mail. So guys, are you able to email ID, please? Email ID is already available inside your dashboard. Everything is given inside your dashboard, right? So not to worry about anything. Yeah, Satya, I'll check your link for sure. If you can send me your link over to a mail, it will be easy for me to track it. Yeah. So fine. Yes, Malikarjun. So fine, guys. I think we have learned something, right, this week. Today's class link was also available in dashboard. Yes, exactly. Everything will be available. Yeah. So fine. Let's try to try this learning, and whatever task I have given to you, do it. Simple. Yeah. So you will not learn much while attending a classes. You will learn a lot when you will try to do it by yourself, and you will try to complete these things. Honestly speaking, I never say that I teach a lot in my classes. No, I just like I give some sort of a guidance, the basic stuff and all those things, right? You actually learn when you do it by yourself. So your actual learning is not your live class. Your actual learning is after a live class, right? When you will do it. Yeah. So with that, fine guys, thank you so much for your questions and everything. And let's do it. Work, just work. Do we need to create a form or a feature and deploy it in a Heroku for prediction? I'm just leaving up to you. I'm not going to give you guidelines over there. So when I have to discuss, I'll discuss in my way, right? But the same example in all the cloud deployment, I'll show you. This is your time, so you have to decide. Please review my last task. I think whoever has sent a mail till yesterday night, all the mail I have cleared, right? Last Sunday, no, Neil Khan. So I think what I believe is your mail is already like checked. Are you talking about internship or task? Task, if you can tell me your Neela, what is your email ID by the way? Anyways, I'll do a second one. My last Neelkanta 81 at the rate Gmail. Okay, so I think I have assigned you to a Sorgansu, right? Yeah, so I think I have already assigned you to a Sorgansu. So he will respond back. So generally what happens is if there is some task which I want my team to check. So in that case, I just assign these things, allocate this task to my team. So Nilkant, for you, it's already assigned, right? Mine is assigned to Vikas. Yeah, so you can do a follow with them. So they will assign. So I just distribute all of this task, check and everything to all of my team members. Some of the tasks I used to check, right? But I'm doing it. So I know I have responded back to almost every mail, not almost every mail, to all the mails, right? Either I have assigned or I have replied back till yesterday night. So my mail is clear. Today, I'll do it. Response to our mail, thanks a lot. Yeah, I always respond back to like and most of your name I remember because yeah, I like remembers everyone's name. I'll check, sir. Yeah, Nilkan, I can see like your mail chain. Can I be also added to this internship program as I'm new, so I don't internship wise you have to start your own internship and then you can start dropping us a mail that okay fine, so this is the task I have done and this is something that I'm like trying to do. Vikas Kumar Mishra. Okay. Have you sent a mail at query? Because I'm not able to see your mail on query. Okay, I can see your mail. Okay, on my personal mail ID. Okay, so maybe that I have not responded back. Okay, fine. I'll just like respond. I'm just forwarding this to my query account because query and internship. So I'm taking care of these two mail ID. So whoever sends a mail on this two mail ID, immediately I used to respond. Even like a response time is lesser than my personal mail ID. So I should respond my personal mail ID in a later stage, but these two mails are like a priority for me always. Email your personal line. Why is it mark in CC if you have assigned my query to someone else? I require to mark in CC? Yeah, so whenever you are like sending something, so always mark me in CC. In this way, I'll get to know, right? So whether my team is replying back to you on time or not, and what is the hurdle. So if they are facing some hurdle, so maybe we can handle. Yeah, so with that, yes, Mohit, I will try to check. Mohit, I think your is clear. So I have responded back to your mail so many times. Ankit, Sheikh Kumar and Ankit. Yeah. So I forwarded those to Gary guys. Okay, then it will be responded. Yeah. So email IDs are scout for our internship. Our forwarded email IDs are scout for our internship. Yeah. So scout for your existing queries or existing like a hurdles that you are facing. So this is how things happen. So it's a scout for your thing. That's the reason. So I'm assigning this thing. So sometime I used to assign this mail to Sivan or Vasant or Vikas or Imran, sometime Kausali, sometime Ravi, sometime Paul, sometimes Sunny Savita, sometimes Sunny Bhavin Chandra. So all of these are my team members, and you will be able to see like another person's mail ID over there, which I have attached. So those are nothing but those are just a guide for you for that particular instance, for that particular query. Logical relay just for the clarification. Yeah. So fine, guys. Thank you so much, and see you again in your next class. And I'm expecting you to complete a task, right, religiously. So just try to complete a task. Try to do something innovative, a different thing, right? So PyPy. So just try to focus more on PyPy part. Yes. So that you can teach how to productionize your own Python code, whatever code you are going to write. So how to productionize it, so that entire world will be able to use going forward. Yeah. So with that, thank you so much, and see you again in your next class, which is going to happen on Saturday. Before that, we have a doubt clear session, which happens on every Wednesday. So on a scheduled time. With that, thank you so much. Have a great day, night ahead. Thank you.